Welcome back to Advent of Code 2018. Day 18. So, something to do with trees. Okay. Alright, settlers of the North Pole. On the outskirts of the North Pole base construction project, many elves are collecting lumber. The lumber collection area is 50 by 50. Each acre can be either open ground, trees, or a lumber yard. You take a scan of the area. Alright, so we got input. Okay. Strange magic is at work here. Each minute, the landscape looks entirely different. In exactly 1 minute, an open acre can fill with trees. A wooded acre can be converted to a lumberyard, or a lumberyard can be cleared to open ground. The change to each acre is based entirely on the contents of that acre, as well as the number of open, wooded, or lumberyard acres adjacent to it at the start of each minute. Okay. Okay, so it's a game of life, basically. An open acre will become filled with trees if 3 or more. Okay, fine. I know how to handle this. Alright, and then there's the example. Yeah, okay. And you want to take the number of trees multiplied by the number of lumber yards. Okay. Alright then. So. Let's get the input. All right. So we wanna. Okay, first let's just capture the grid. Alright, so we just take the characters, okay. Okay, so I guess we just want define get next grid given a current grid. Alright, so we're given a grid. We want to get the next grid. So create Grid of, okay, new grid equals, so it's gonna be none for range length of G0. Length of G. So I have the same dimensions. I guess it's a square, but it's whatever. And we want to say, we want a helper method here. Let's say no, we don't need a helper method. Okay, just say for I in, you know, it would have been better if we did this. Let's say M equals length of G0, N equals length of G, and then just do this. Okay. For I in range M, N, or J in range M, we're now going to see what the new grid at this location should have. So it should be okay, so we're gonna have to check all the neighbors. Let me just have a quick read again. Adjacent means the 8 around. Okay, all right. Okay, so basically we want a variable which is num trees and num lumber yards, bit of a long word, 0, 0. So we want to just count all the cells around. So we want to do for di in -1, 0, 1, or tj in -1, 0. So we're going, if di is 0 and dj is 0, then skip that one. So we're going for the 8 neighbors, excluding the middle. We also need to make sure, okay, so if so neighbor I equals I plus di, neighbor j equals j plus dj. If, so it's got to be 0 is less than or equal to neighbor I is less than n, and 0 is less or equal to neighbor j less than m. This is standard neighbor checking. All right, then if we're this far, that means this is a neighbor. if G neighbor I neighbor J is a tree. So that's what? A vertical line? Let me check again. Yeah, vertical line. Alright. Num trees plus 1. Elif. Equals hash. Then we have a number yard. Huh. Alright. So outside of this, okay. Yeah, alright, that's quite wordy. But that's how you get neighbors. Now we know how many trees and lumber yards are nearby. So alright, so what are the cases? The cases we have are if we're open, alright. Okay, if G I J equals dot, so if we're at open, now if there are 3 or more trees adjacent, okay, so if, hello DJ, if num trees is greater or equal to 3, then new grid IJ will be a tree. Otherwise, new grid will just be a empty space. What's wrong with this? Alright, it doesn't like that. It's fine. Alright, the other case is if we are a tree, then if there are 3 or more lumber yards, then we become a lumber yard. Otherwise, we remain a tree. And then the final case, we are a lumber yard. If there is at least 1 lumber yard and at least 1 tree neighboring, then we stay a lumber yard. Okay, so if so we got num trees is greater or equal to 1 and number lumber yards is greater or equal to 1, then we remain a lumber yard. Otherwise, we become open again. Alright. Then after all that, just return new grid. Okay, so that's one step. So what do we want to do? We want to apply 10 iterations. Evo Dev Team, thanks for the raid. We're doing some tree planting. It seems to be game of life, but using trees and lumber yards instead of whatever it is that is used in game of life, some sort of organism. What were you streaming? I want n equals 10. All right, no, okay, so for 10 steps, Phasmo, Four Guys, Scum. Okay. Okay, well, yeah, I'm doing day 18 of the Advent of Code 2018. I guess I'm in the final third of the problems. I've been on it for the past... Hang on, let me... actually post a link here, in case anyone wants to actually see what the problem statement is. That's the problem statement. I think I'm almost done with this particular problem. Then I'm on to part 2. I mean, long story short, it's just you have that, which is a bunch of empty spaces, trees, and lumber yards, and then every iteration they follow some rules. So if you're a tree and you have 3 or more other trees nearby, or there's certain rules about what you're allowed to become depending on what you were and what your neighbors were. So that all happens simultaneously for one iteration. All of these change to other symbols depending on those rules. And I just have to do that like 10 times basically. So I guess I want to do grid equals get next grid of grid. And then if I do that, now they want us to, oh, okay. We need to now count up the trees and lumber yards. So we want to say num trees num. Oh, this is a bit zoomed out. Hang on. There we go. Lumber yards equals 0, 0 for row in grid. Num trees plus equal row dot count vertical lines, and then we want lumber yards plus equal row count hash. All right, and then what gets you into the mood for code? Gets me into the mood. I don't know. I think I'm always sort of in the mood, although I don't usually code. I think I'm at any time I can just open up code and code. I've never really not been in the mood to code, unless I'm kind of tired. But no, I can pretty much just pick up code and any time really. I don't feel like I have to motivate myself. I mean, lately I've been doing these Advent of Code things during the daytime, rather than the evening, and then in the evening I play games if I'm streaming, but I have been known to code in the evening too, so... Code for me is sometimes like pulling teeth. We had a couple of tough problems. Yeah, I mean, there were definitely one or two where I did stop the stream after solving part 1 without solving part 2, just because it was racking my brains too much. But that only happened a couple of times, and those were particularly tough problems. I still managed to get to a finishing point in the stream, just I didn't manage to finish the whole problem, just one part at a time. So this, okay, now that if I just print this, this should be the answer. Num times num trees. Alright, let's try this. 558960. Correct. Okay, that was conceptually easy, but coding wise actually that's easy to stumble on, because you got to make sure, like if you're on the corner, you got to make sure you're only checking the neighbors, you know, left and down and not off the grid. So you need to do proper neighbor checks. I mean, that's routine stuff, but it's easy to get wrong. Gotta get your indices right. So yeah, I wouldn't say that was an easy problem, just oh, okay. But now we've got the tough one. What will the total resource value of the lumber collection area be after 1 billion minutes? Okay, clearly we're not going to run this a billion times. So they're looking for something clever. You want to find the stable state. So I'm guessing... I mean, this is the thing about Game of Life. Sometimes some initial states result in stable states, where it just stays fixed forevermore. Some result in infinite states, like things which keep moving. I'm guessing this stabilizes somehow. So if we look at the rules, so open becomes trees if 3 or more adjacent are trees. Okay. Similarly, trees becomes lumberyard if 3 or more are lumberyards, and then lumberyard so could I just run it like 1,000,000 times and see what we end up with? But it might actually continue changing, but follow a pattern. I mean, in this example, it looks like we're tending towards just being empty space. Do you ever mess with Visual Script, like blueprints with Unreal? I think I have tried, in the past I have tried Unity's scripts. I don't know what language is used in Unreal. I've done similar stuff, but not... Actually, I have done something with Unreal, but that was many years ago. I think it was a game jam, but we just a bunch of people in a Discord. We were trying to make a 2D game, but it kind of didn't. We didn't even finish in time for the submission. I guess I'm just gonna have to try this and see what it looks like. It looks like it's gonna stabilize, but then it might not. It might actually just go in a repeating cycle or something. So let's say... Let's do 1,000,000. But if every 100,000 we'll print the grid. So let's do this. Let's print... Just leave empty spaces either side. Print joined up. So we're doing it 1,000,000 times, and then we're printing every 100,000. See what it looks like. All right. We can't even make it to 100,000. Because the grid is like 50 by 50, so that's, yeah, that's too many. Okay, scale down the numbers. Let's go for 100,000 and every 10,000. Oh, hang on. Print. Alright, just print empty space. I don't think that doesn't print a new line. Okay, start again. So that's the initial grid. Okay, even this is too much. Whoops, okay. 1,000 then. Okay. Whoa, look at that. What the heck? Is it stabilizing? I can't tell. Yeah, it looks like it's stabilizing. It looks like it's completely stationary. Wait, is it? No, not yet. No, it's actually it's still moving. No. It's actually doing something. Yeah, it's not stable, but it is following a pattern. I think it's like these loops are growing outwards. So I need to spot the pattern. Oh man. Okay. In that case, what are we gonna do? We can say... So first we need to find out when it repeats. So we need to find the period. How many steps it takes for it to repeat. Once we know the period, then it's just a modulo operation, isn't it? We just need to... Okay, how do we do this? I'm gonna have to make a hash map. Okay, we'll take this out. Okay, so we want to say, okay, so let's we've got a list. I mean, we gotta turn it into a tuple or a just a string. Let's do a string. So we'll say, let's say signature equals. So we want join, and then join row for row in grid. So each row gets joined up, and then individually, and then those rows all get joined up together. Let's try printing sig. It should just be a long string. Yep, okay, I've got it. Alright, so, ooh, that's cool. Now we want to say if sig in table. So if we've already found sig before, then we now know the period. Period equals step minus whatever it was before. Okay. Then print the period. Let's see if we can find out what the period is at least. And break, I guess. Otherwise, put it in the table. Table sig equals step. So we're recording the time of each signature. Let's try that then. Also, okay, the period is 28. What do we do with that? We want to know what billion, what it'll be at a billion. So we want step to be what do we do now? We want a billion modulo 28. When we get to that step, so when step okay, right, to begin with, period is unknown. Okay, we don't know what period is. Take that out. So the moment that we find it in the table, then we know the period. But we don't break, we carry on. If period is not none. Okay, that means we now know what the period is, and we know it's actually 28. So we're going to say if 1 billion percent period is equal to well, technically we want step to be 9999. Okay, it's gonna be this. Hang on, so it's gonna be, what should we just do? That -1. So if we want step to be that, so if the step is a billion, basically, or the 9999 whatever, on that period cycle, then we know what we would get if we really did count up to a billion. It would be this. We'll just do this. We just break. So grid will be whatever it will be at a billion, right? Because it's going on a cycle of 28. So then you just do this? I don't know. Does this seem right? So you could try running it. Stop printing stuff. Stop printing stuff. Take that out. Alright. So oh, no, wait. No, this is not right. Hang on, what do I actually mean here? No, I don't mean equal step. I mean if no. This should be ifs. This should be, it should be the same modulo. In other words, yeah, it has the same modulus as the step. That's what I meant. Okay, go. There we go. 207,900. Correct. That was a good problem. Yeah, you just gotta find the pattern. So my first thought is it might stabilize, but then yeah, it's like Game of Life. Game of Life does actually have infinite cycles that can be stable or unstable. This one is sort of, it's stable. It's just repeating. So you gotta identify the period of the repeat. Once you know the period, then you can work out what it will be at a billion, a trillion, quadrillion. Yeah, good problem. How did people find that? Interesting. They found it easier than the recent questions. I still thought it was hard. It's just it's just fiddle. Okay, that period stuff is actually a bit fiddly to code, but it's not conceptually difficult. So I think even people who didn't know strong algorithms or anything would be able to do it. They'd realize they just need to find the pattern. And once they find the pattern, then just extrapolate to a billion without actually doing a billion steps. Yeah, I think, okay, yeah, that's not that hard. Okay. Am I just gonna leave it at one problem a day? I think I might have to, because these problems are starting to take about, well, okay, that only took 45 minutes, but the next one may well take an hour or more. Yeah, I might need to go back to one problem a day. Let me think. So, yeah, okay, that's it. Just problem 18. We can have a sneak preview of 19, maybe. Of course. It's bloody assembly code again. This one looks different. Well, they all have their own quirks. All right, well, that'll be fun next time. Okay, that's problem 18. Thanks for watching. I'll see if I'll have time tomorrow to do 19 or sometime in the future. Bye-bye.